Hi everybody, today I want to introduce you to two persons, Deep Dive Danny and Jumpstart Jamie. Who is Deep Dive Danny? Danny's passion is Python's intricate details. From meta classes to global interpreter log, he knows it all. But when it comes to actual projects, his confidence wavers. He believes he needs to learn just one more thing before actually starting with the project. His vast knowledge remains largely unapplied, leaving him with an empty portfolio. And then we have Jumpstart Jamie. After her first Hello World, Jamie leaped into Django, then Flask, then into AI. Each time she was drawn by all the allure of a new trend, but retreating at the first sign of complexity. Her journey is a trail of unfinished projects, each abandoned for the next shiny tool. Can you relate to one of them? Drawing lessons from Danny and Jamie, it's clear that veering too far into any learning direction isn't beneficial. The Pareto principle suggests a more balanced approach. 20% of the right effort can unlock 80% of the desired outcomes. It's not knowing about every detail of a language or chasing every new trend. Instead, focus on the foundational 20% of Python equips you to handle a vast array of projects. In this video, I will show you what I think, a software engineer with several years of experience, what you actually need to know before learning a framework. So in this video we start with the very basics, but it's quite in a fast pace, so maybe a little bit of Python knowledge helps you to follow along. As always, you can find the link to the code in the description. Okay, I'm here in VS Code, and as you can see, this includes our project. We start with the very basics. These are the essential programming skills you should learn first when you're learning Python. And we start with a very basic syntax. And in Python, you start a comment with the hash symbol, and if you want to print a string or a number or anything, you use the print statement. So normally you start in every language with print hello world. This is how it's done in Python. Then we go to variables and data types. There are four important data types: integers, floats, strings and booleans. There are more, but these are the most important. We can assign any data type to a variable. On the left there is the name of the variable, then follows an equal sign, and on the right we have the integer. Again, for the y, we've got a float. A float has got this little dot, so you've got 5.0 or 5.1, so this is a float. Then we've got a string. A string starts with double quotes and ends with double quotes, or starts with a single quote like this and ends with a single quote. You cannot mix it, and the normal convention in Python is to use double quotes. Then we've got booleans. Booleans are there to check if something is true or not. So for example, you can check if 5.1 is larger than 5, is that true or false? So this will be a Boolean value. Okay, let's go to the conditionals. Python supports the usual logical conditions. For example, you want to compare two values, there you use double equal signs. You can check if they are not equal, you do it with an exclamation mark and an equal sign. And you can also check, are they less or are they larger than a specific value. For example, we can use then an if statement to decide which code will be executed if a condition is true or false. So in this example, we assign 18, the value 18, the integer 18, to the variable age. And then we use an if case and check, is age larger or equal than 18? And if that's true, this will always return a true or a false, so a Boolean value. Then we will run into this code part, and otherwise, if that's not the case, we will execute this code. So what do you expect? As you can see, we get adult. Okay, let's go to loops. Loops are there to execute code multiple times. And we've got two primitive loop commands, for loops and while loops. So what's the difference? In a for loop, you've got a defined range or an iterable, which contains, for example, 100 objects. And we iterate over each of the objects. For example, we've got in this range here, we've got then 5 elements, and we will print each of the elements. We started with a for keyword, then this is a placeholder of each iteration, and we can do anything, whatever we want. We can, for example, multiply this by 2 in this part. So this is indentated here again. So we use indentation here in a for loop too, like in if statements. And for example, if you run that, we can see that now we print 0, 2, 4, 6, and 8. So for each iteration, we start with 0 here. Then we go to 1, 2, 3, and 4. So this is how a for loop works. So then we've got while loops. While loops will work a little bit different. We often use them to run code in an infinite loop, but we can also exit from a while loop. So for example, we start with a value with 0, and then we update the value in each iteration. And here we add 1 to this I value. So in each iteration, we print the value and update the value. And as long this is true, so this gets updated. For example, in the first iteration, it is 0, then it's 1, 2, 3, 4, and 5. And if that's false, the loop will then stop executing. So here we've got 0, 1, 2, 3, and 4. So in the example I provided you, the for loop is definitely the better one. The while loop is more used when you don't know exactly when to exit from a loop. Okay, let's continue to typecasting. Typecasting means converting one data type to another. This is quite easy. You can use the built-in float function, integer function, or string function to convert any kind of data type into another object. So for example, if we've got this integer 5, we can convert it to a float, and we can also convert a float to an integer, and this will be rounded. For example, if we make this 5.4, this will be at the end. Let's just print it here. So this will be 5, and this will be a string of 5. The print statement actually looks the same, but this is of type string now. So, but what would happen if you try to convert, let's say, not this 5, but the name John to an integer? This would now look different. So this would raise an exception. As you can see, this produces a value error, and we can work with these kind of errors. I will show you how to do this here in the exceptions part. So if we try to divide 10 by 0, this will of course also raise an error. We cannot divide by 0, mathematically not possible. And this 0 division error we can try to catch and then do something with it. So we can make like this, a try statement, and then try to execute this code. If it runs into an error, we could now just do it like this. So we would catch any error, or we can catch the error by its name. So we can only catch this 0 division error. And if that's the case, then we will make a print statement or log it or do whatever you want. So this is helpful for debugging applications and not to produce runtime errors. Okay, as you can see, now we don't have this error here, which would crash our application or our code, but we just get it here in the print statement. So this is very helpful. Okay, then we can also do it like this. So for example, this works the same. We now raise, or we now print the error, but then we raise the error. So this is very helpful if we want to do something user specific. For example, we wanted to send an email to a user or just execute any kind of code which would help us to debug the application. So this can be done like this. So this is the same like here, but we can actually write custom code before we actually erase the error. Okay, now let's go to functions and built-in functions. Functions in Python are defined by the def keyword, and there are also many built-in functions provided by Python. So you've already learned the str function to convert, for example, an integer to a string, or the int function, and these are the built-in functions. For example, we can use the len functions to prove or check the length of this string and assign it to a variable. So this is a built-in function, and this returns the value 6. And if you want to create a custom function, we have to start with the def keyword. And here we have to give the function a name. So this has to be unique in our code, in our namespace. And then we can also pass parameters here. So for example, we've got this function. This takes a single argument, and we just return the string hello and then the name. So if we run it, we do it like this. We use curly braces and pass in this argument. So this can be done like this, just as a positional argument, or you can also say name equals max. So this is the same, and I think with actually specifying here this as a named argument, this is the better code. So this returns now hello max. We can also define default arguments, and in this example we've got our greeting. This is by default hello, and then we can also pass a name. So this will be the default greeting and then followed by the name. So if we now run just max and leave the greeting variable empty, then this will return hello max. And if we specify the greeting variable or argument, then this will return hi max. As you can see, now we've got hello max and we've got hi max. Okay, now let's continue to the next greet function. And as you can see, we don't have a single name now, but we've got this names argument, but this has got this little asterisk. And this little asterisk means that we've got multiple names. So we can define as many names as we want. So this will then be a tuple. And what actually a tuple is, we will learn a little bit later, just in a few seconds. So we can use this now to loop with a for loop over these names and then greet multiple persons. For example, we do it like this. We now greet Max, Anna, and John. And we can also override the default welcome message. And instead of hello, we say welcome. So if you run this, we now get hello Max, hello Anna, hello John. And then for the second function, we get welcome Alice and welcome Bob. Okay, now let's get to our most complex function. And this is the same as before, but we've got this extra argument here. And this has got two asterisks and they are called extra greetings. So this is called kwargs, keyword arguments. And with a single asterisk, it's called args. So arguments and keyword arguments. And the keyword arguments are a tuple and the extra greetings here, the keyword arguments, are a dictionary. Again, we will look at the details of tuples and dictionaries a little bit later, but we can use that to then loop again over this dictionary. And what actually the syntax mean, we will look a little bit later, but just to demonstrate you, we can now say we've got hi max, and the hi max comes from this first argument here. So we override hello with hi when we override greeting, and then we just iterate our first time, hi Max, hi Anna, and hi John. So here we only got positional arguments, and for the named arguments, which will be our extra greetings, we can say now welcome Alice. So this is the personal greeting, welcome, and the name. So we extract that here and just print it in this way. So we've got 2 kwargs and 3 args. And this leads to the difference here in the output. Okay, now let's go to the data types that actually are behind this args and kwargs. And we've got lists, tuples, sets, and dictionaries. These are the most important data types in Python. A list is there for ordered and changeable values. A tuple is there for ordered and unchangeable values. Then we've got a set that is for unordered and unindexed and only unique values. And then, very important, the dictionary is unordered, changeable, and indexed by keys. So what does this exactly mean? So first we create a list. So a list starts with square brackets and then you input the values. So in this case, we've got a list with 3 values, 1, 2, and 3, and we can use methods. A method is a specific function belonging to an object. So we can use this append method to append 4 to this list. So this list now has got 4 values, but we can also change the value like this. So to change a value, we have to write the name of the variable and then use square brackets. And in here, we use the index. For example, the index tells which element it is. Index 0 is this 1 here. Index 1 would be this 2, and index 2, so exactly this value, would be the value 3 in this case. So we would override the value 3 in this list with the value 2. So at the end, if you print the list, we can see that now we've got 1, 2, 0, this was changed, and 4, this was appended by this append method. Okay, let's go to the tuple. Tuple looks like a list, but instead of square brackets, it has round brackets. So we've got 1, 2, and 3, and this is a tuple. So the main difference between this list and the tuple is that we cannot change a value. So if we try the same like here, so we try to change the 3 here to 0, If you run that, we can see that we get an error. Tuple object does not support item assignment. So this is unchangeable. That's the main difference between a tuple and a list. Okay, let's go to the set. So a set is, again, here unordered and unindexed and can only contain unique values. We can create a set with curly braces and we use the values 1, 2, 3 and 3 here. As you can see, we've got duplicated values here, 3 and 3. And if we would print that, it would only contain 1, 2 and a single 3. But we can add values and we can also remove values. So this is changeable in contrast to the tuple. And if we print that at the end, we can see that this was the first print statement, 1, 2 and 3. And the second, we added a 4 and removed the value 1. So we only got 2, 3 and 4 left. So we can not only use the brackets to create a set or work with a set or tuple or list, but we can also use the built-in function to work with it. And here I show you a nice little hack. So we can see we create a list, 1, 2, 3, 2, 3, 3 and 2. So we've got multiple duplicated values and we can now call the set method or set function on these lists. And then again, we run the list method of the result of this set. So what we're gonna get here is just 1, 2 and 3. So this is very nice and helpful if you want to extract unique values, but still keep the original list a list. Okay, let's move to the, I think, most important data type in Python, and that is the dictionary. You create a dictionary with curly braces like the set, but instead of the set, you define a key and a value and separate the key and the value with a colon. So we've got the key name and we've got the value John, and we've got another key, age, and the value for age, the value is 30. We can append or update to a dictionary like this. So we use brackets here, square brackets, and pass in a new key and set a value for this key. If that key already exists in a dictionary, we will override the old value, here in this case 30, by the value 31. We can access a value of a dictionary by the key. So we want to get the name John, then we have to do it like this. We pass in square brackets the key we want to access, and this will now return the value John. We can also use some methods, so built-in functions for the type dictionary, and get the keys for this dictionary. So this will return this object here, dict keys, and print all of the keys, name, age, and email. We can also get the values, and the values are then John, 31, and this email john@example.com. We can also use the items method, and the items method will return a list with tuples. So the first element of the tuple is the key, and the second element of the tuple is the value. So this can be done with items. We can also remove items from the dictionary with the pop method, and this pop method returns actually the value of the key we define here. So for example, we pop email and this will return the key. So if you run that here, john@example.com. If you run it again, we can see that it no longer exists. We will raise a key error. So we can only, of course, delete that once. And we can also delete everything at once with the clear method. So at the end, we've got just this empty dictionary. So these are the most important functionalities of a dictionary. Okay, now let's continue with list comprehension and generate expressions. And list comprehensions provide a concise way to create and iterate over lists. So you've already learned that you can run a for loop over an iterable, but you can also use a list comprehension. And generator expressions are very similar, but yield an item one at a time and are so more memory efficient. So maybe before we jump in the list comprehension, I will show you how this code would look like with a normal for loop. So this is the way it looks like with a normal for loop. We create an empty list and then iterate over the range object. So we create 10 numbers and we multiply each number by 2. And then we append this new number to this square list. So this should be familiar now, because everything we do here we already learned in this course. And this is fine. Of course it's fine, but we've got 3 lines of code, and I think it's not the best way to do it in Python. With the list comprehension, you rearrange the code a little bit. So we also got this for loop here, and we've got the same as here. So for x in range, this is the same as here before. And now instead of doing this here, we put everything we want to do with this x placeholder, we put that in front of the brackets, in front of this code snippet here. And here we don't have to create an empty list. So we just use the bracket here to define the return type of this iteration. So we do it like this, and at the end we've got a single line of code and the same functionality as here. But this is far more concise and pretty much the standard in Python. Okay, now let's look at generator expressions. As you can see, these look almost the same, but instead of square brackets, we use round brackets for the generator expression. So what do we get here? So we don't get the actual values like here, but we get this generator object. And we have to use iter and next to get one item of this generator object at one time. So for example, if you run that, we get 0. If you run the code again, we get 1, and so on. And at the end, if there are no values left, we get this stop iteration error. So we can access with this functionality one item at a time, and at the end we raise an error. So we can catch this error here with try and except, and then make everything work as the list comprehension. But we don't put every value in memory. This is especially important if you've got a lot of numbers. Let's say 10 million numbers and you want to multiply them each by 2. This will block a lot of memory on your computer, and for this case you might use a generator expression. Okay, let's move on. And we can also use the generator expression like this. So you can define an own function with the def keyword, and then instead of using a return statement, we can use the yield statement. So this will yield an item one by one, like this, again in this generator expression. So if we can do it like this, we define the function, and then we create our generator. I will just remove that here and print the values. So what do we get here? Now we get a generator object, and we can again use next and iter to loop over that. But we can also just use a for loop and then, for example, print everything we want to do with each value here. So if you run that, now we get the multiplied value here one by one. So this is also possible. We don't have to use next and iter, but we can also just use a for loop. But under the hood, actually, a for loop will use next and iter. But this is a more advanced topic, which I will not cover here. Okay, let's move on to lambdas. What are lambdas? A lambda function is a small anonymous function. It can have any number of arguments. So this is the syntax of a lambda function. And in VS Code, this is quite nice, because when we hover over this function, we can see how this would look like if we define it with the def keyword. So this would be the name multiply. We've got 2 arguments, which can be of any value, and we return something. So instead of using the def keyword, we can make it anonymous. So we introduce a lambda function with the lambda keyword, then we define the 2 arguments separated by a comma, and then the colon, and then we define what we want to return. So we've got 2 arguments, a and b, and we want to return the multiplicated value of a and b. So this is our anonymous function now, which is stored in the multiply variable. And now we can just run multiply on 6 and 5. And in the result, we can see that this returns 30. So if you've got a small and easy function, lambdas can be a nice alternative to using functions with the def keyword. Okay, let's move on to decorators. Decorators provide a way to modify functions using other functions. This is powerful for extending the functionality of your code. So what actually is going on here? We've got a function called wrapper. We print something and we execute another function, and this other function will be passed in a wrapper function. So this is the decorator. This is wrapped around this inner function. and we pass in a single argument, which is a function, and this function will be called inside here. So we can actually do something before the function we pass is executed and something after this function is executed. And at the end, we don't call it here, so we don't call the wrapper, but we return the wrapper. So we can, in Python, pass functions as arguments and return just functions from another function. So this makes Python very convenient and allows this special decorator syntax. Okay, so now let's use it. We can see we define a function called sayHello. It only prints hello, and we pass the sayHello function as argument to the myDecorator function. So what will happen here now? We pass it as argument, and then we've got our wrapper function, and inside here we will actually call this function. And before the execution of hello, we will print this, and after printing hello, we will print this. At the end, we will just return that. So when we call that function, it will not execute the function, but return that wrapper function. And now if you run the function, so this is actually the wrapper function. So this will execute the function we passed in as argument and then actually make the print statements here. So if you run that, we can see that now we've got hello and we decorated it with this code executed before and this code executed after this function. Okay, instead of doing it like this, so instead of calling the actual decorator, we can just do it like this and pass it with this add symbol and then the name of the decorator function. So this is the way you normally will see decorators. It works exactly the same. So we can just decorate it here and then just call this original function. So if we do that, we can see that this will exactly return the same as here. So that's the better and more convenient way to work with decorators. Okay, there's only one problem with our decorator. The problem is that we don't allow for arguments in this function. So if we would allow one argument like a and a here, we would allow exactly one argument. But this would of course not be dynamic. So I show you a better way to do this, and this will be shown in this real world example. So again, we've got our decorator. This is a timer decorator. And again, we allow for a function, but in this case, the wrapper function allows for args and kwargs, and this will be just passed on to the function. So it doesn't matter how many arguments this function has, we want to use the decorator with. It will always be correctly extract the correct arguments and keyword arguments, and this will make the function dynamic. So this would be a timer decorator. So it calculates the start time of the function and the end time, and we can use this decorator to see how long this function takes to execute. So we can, for example, sleep here, and then we can see that this function now executes in around 2 seconds. We can see function finished and elapsed time. So this is a nice and convenient way to create a decorator to measure execution time of your code. Okay, let's jump to another topic I think every developer should know a little bit about. It's regular expressions. You don't have to be an expert, but regex is quite helpful for searching, matching, and manipulating strings. And Python provides the RE module, which you can import with the import statement. So we can import RE and then use the search method. For example, here we pass in a raw string and we want to search for the apple in this string, and this will return at the end, if you execute it, an RE match object, and we can see the match happens here from the 11th to the 16th element of this string. So we can see we've got our match here. Okay, let's move on to a little bit more complex example, and instead of just search, we use find all here. And this is the way normally a regex looks like. So we've got this backslash, a D, and a plus. And the first two symbols here, the backslash and a D, means search for any decimal, so from 0 to 9. So the plus means match 1 or more digits in this case. So if you run that, we can see that this will return a list 1 to 0 and 4, 5, and 6. Okay, now let's have a look at a real world example, and we define a function called has uppercase, which we can pass a single string as argument, and we search for an uppercase A to Z, so we wrap that in brackets, and if that's the case, we return a true, otherwise we return a false. So we define this string hello world, and now we check for uppercase, and if that's true, we will return the print statement the string contains uppercase letters and otherwise does not contain uppercase letters. So as you can see, this string contains uppercase letters. So this is a little bit a more realistic example of a regex. Regex is very helpful to, for example, extract emails, telephone numbers, and so on, and you can find a lot of predefined regex already in Stack Overflow or whatever you want, and you don't have to be an expert, but make sure you know at least the basics of regex. Okay, after learning the basics, then we can go to object-oriented programming, and we will define some heroes in this case. So we will define real-world objects, and everything starts with the class keyword. A class is a blueprint that defines a structure and the behavior of an object. And we will start very simple by creating a generic hero class. To create a class, we use the class keyword and then define the name of the class. In contrast to a function, we make the first letter uppercase, so we define our class hero, and then inside this we use indentation to define the elements of our class and also the behavior of our class. Normally classes have this special function, underscore underscore init and underscore underscore. This defines the attributes of our class. So each hero will have a name and a level. So the first argument of this init function or init method is self. So the self actually refers to the instance of a class. So let's say we have a blueprint, and with this blueprint we create three heroes, hero A, B, and C. Then we've got three instances of a single class hero. So we attach the name and level argument here to the instance, so to self, of that hero. The same applies for methods. So when we pass in this argument self here, we tell Python that this describes function is a method of hero. So this belongs to the instance of the hero that we will create. And this will only return the name and the level of that hero instance. To create an instance, we will use the name hero and then use normal brackets and pass in the arguments. So these are the arguments for the constructor, so for the init method, and this will now be max. This is the first argument and the level is the second argument. We can also use named arguments, but positional arguments are fine too. To access the attributes, we can use a dot. So hero.name, or we can use the method here, hero.describe, but since this is a method, we have to call it with another brackets. So let's do this, and we can see, first we have to, of course, create the class here, and then we can create the instance. So we can see to access the attribute name, this is max, and now we call the method, and this will return max and level 5 hero. Okay, now let's have a look at the internals of classes and instances. And I think this is quite important to understand. So we modify the hero class a bit. And as you can see, we pass in this weight variable. The weight is 100. And this is nothing inside the constructor, but this variable belongs to the class, not to the instance. And now we use just that same code, but with this weight modified here, and create an instance of the hero. The name is Merlin and the level is 10. And what we can do now here is we access the attributes with this special underscore underscore dict underscore underscore attribute. And if we take a look at this, we can see this is a so-called mapping proxy. And the mapping proxy is a read-only dictionary of the class. So this is not the instance, but actually the class blueprint. As we can see, here we've got this attribute weight. Okay, that's fine. If we access the dictionary of the instance, it looks a little bit different. And as we can see, here we've got name Merlin and level 10. So that's quite nice because Python stores our attributes just in a simple normal dictionary. But what happens if we try to access the weight here with the dot syntax? Do you expect an error or what do you expect? So if you run that, we can see we get the correct property here, so the correct attribute, but it's actually not in a dictionary. So what happens here? So if Python is not able to find an attribute in the instance dictionary, it looks for the attribute in the class dictionary. And if that's also not found, it will raise an attribute error. So if we change that, then we can see we will get an attribute error, but otherwise, if we try to access the class variable, it works just fine. Here you can see how you can actually access the value weight here from the class. This is not recommended code, but just for demonstration purpose. So this is the instance and we access the class, and in this class we access then the class dictionary. So this is how you can access the mapping proxy from the instance. Let's now continue with inheritance. Inheritance allows a class to inherit attributes and methods from another class. So we can use the hero class and derive other classes, so other blueprints here from that hero. So instead of just creating a class, you pass it here in brackets, the class you want to inherit from, and this will inherit the attributes and methods. So you can override then the describe method, for example. So we defined it here, and now we can override it here for the archer. So let's do this. Let's create now an archer in the wizard and run the describe methods here. So this worked, and as you can see, we did not have to define the name and level in the constructor. So that's not necessary if we use the same attributes for the derived classes. Okay, now let's go to the super keyword. So why do we need this? Let's say we have our archer and we don't only want to have name and level, but for an archer we also want an arrow count, and for a wizard we also want a spell count. So these are additional attributes, so we need a constructor for the wizard and for the archer class. So we don't want to recreate name and level with the archer class itself or the wizard class, but we want to take the name and level from the hero class. So that's the parent class or super class. So this is why this is called supers. So we call the constructor of the super class and only use our constructor for the archer here to define this arrow count attribute. But otherwise, this will be done in our hero class. So let's run this. So as you can see, this works fine. We create now an archer and a wizard and run the describe methods. Yeah, this works. So for the archer, we've got arrows, and for the wizard, we've got spells. We could also make it like this. So we use hero in this case, and we run the constructor, but here we have to pass self. So if we run that, we can now see that this code works exactly as before, but actually this is not a very good practice, because if we want to change the hero class, we will then update the name here. So super is a more generic way to achieve this kind of functionality. So always use super and don't call the actual class here. Okay, now let's go to private attributes, getters and setters. So in Python, you don't have private attributes. Maybe you know a little bit of Java or anything. There you can set a private attribute with an underscore, and after that you cannot access this private attribute. In Python, there are no private attributes. So if you want to set an attribute to private, this is only a programming convention. If other programmers see an underscore, they know they should not access or modify this private, so-called private property, and instead use a setter or a getter method to actually access it. So a good way to abstract this away from other developers is to use a property decorator and use a function. This function should have the same name as the private attribute, but without the underscore. So you create this function with the def keyword and not a single argument here, and then just return from that function the private attribute. So this will now use the getter the getter function, and we have to set this property decorator. This is built into Python and allows you to do the following. So this is a normal method, and you would access this level like this. You would call this method, but with the property decorator, you make that function look like a normal attribute, but actually under the hood, this is still a function, but you don't have to use brackets. So it will look like an attribute, but actually it isn't. You can do the same for a setter. So when you want to update the level, for example, you use this setter function. So you use an @ symbol, then the name of this function, and then a dot setter. So this comes from this property decorator. So this allows us to set values. And if we modify it like this, it will now make checks like this possible. So we check for the new level, and if that's larger than the new level, it will assign it to this private attribute. Otherwise, it will print an error statement. So the new value of a level has to be greater than the current level. So we can create custom checks for setting this attribute. So we will not directly modify this attribute, but we will use the special setter method. But keep in mind, this is only a convention. We could still do this. Now if we take a look at this, we can see we use the getter function to get this level, and it will return the value 5. And the underscore method will also return the level 5. Because, yeah, it's just a convention, but it will not use the getter function. If you want to update this level and set it to 3, we can see invalid level must be greater than current level 5. So if we change it to 6, this should work. We can see we don't get an error. And otherwise, we are still able to modify the value if we take the private attribute and just modify it. So keep in mind, if you don't want any other developers modify your values, or you come across a private attribute in other people's code, don't modify it yourself. Okay, now let's move on to the so-called dunder methods or magic methods. You already came across this init method, and dunder means double underscore. So if a method starts with 2 underscores and ends with 2 other underscores, that's a dunder method or a magic method. So why magic? So let's look at the example in Python. You've got, for example, 3 plus 4. And this will, under the hood, call the dunder method of the integer class. So this will actually do this. Int, and then we have this underscore method, and then we pass in a first and a second argument. So this is actually what's going on when you type 3 plus 4. So this is exactly the same as here, but of course this is not human readable, or not very good human readable, and this is the way we normally expect mathematics to look like. So this works, as you can see, no errors, and it absolutely returns the same result. So this is nice to know how this works under the hood, and you can use that kind of functionality for your custom classes too. So for example, we can use __ str for describing our class. So for example, if we currently do it like this, hero, then we can see this just gives us back the point in memory for our class. But with the str method, we can modify that behavior. So we use str to make that look a little bit nicer, and also allow using the add method here to actually add heroes. As you can see, we add the self level and other levels. This is just for demonstration. I think it's not really worth it, but yeah, let's try this. And maybe at the end also, yeah, you can see it here, print hero 1 and print hero 2. We create 2 instances. So now we want to add hero 1 and hero 2, and we can see this should now return 10 because we add 5, level 5 and level 5. So we can see hero 1 looks like that, Merlin level 5. So this is what we provided here. Here in the str function, and for hero 2 this is the same, and for hero 1 plus hero 2 we can see that we now return Merlin and Melchior, level 10 hero. Okay, now let's use our classes here in combination with other classes. We will modify the classes a little bit. So what we will do now here is we remove the getters and setters and just inherit here from hero, and override the describe function by actually calling the superclass. This is of course also possible, and just print here the arrows for the archer and the spells for the wizard. So let's create this function, and now we can create another class called team, and in the constructor we pass in args, and our args are actually heroes. So what we're gonna do now is we want to loop over each hero and call the describe method, but we want to do it from another describe method, which is the describe method of the team. So let's create this, and now we can create an archer and a wizard and create a team with an archer and a wizard. So if you run the describe method, we can see, of course, we use the getter again from the base class, and now we can see Robin level 10 hero and arrows 20, and Merlin level 12 hero, spells 5. So okay, now let's go to abstract classes and methods. Why do we need abstract classes and methods? So let's say we have a hero class, and that hero class is actually a class we don't want to use, but we only want to use archers and wizards, but we never want to directly work with this hero class. We can of course instantiate a hero and just use it like a wizard or like an archer. But if we don't want that, we can make it abstract, and we import from ABC the ABC class and also the abstract method. So we now let the hero class inherit from that ABC class to make it abstract, and we can now define our abstract methods. So instead of the describe method we use here, we define it as abstract method. So I will show you just in practice how this now works. So if we create an archer based on that hero and we don't implement this describe function, we can see this now, we can see that we can't instantiate an abstract class archer with an abstract method describe. So this abstract class forces us to implement a concrete method describe for this archer class. If we override it, as you can see, this is be done here, we can now instantiate an archer and work with it. Okay, that's it from object-oriented programming. Now let's go to type hinting. Type hinting allows us to create better software, and I will show you why this can be helpful. For example, we've got this team class, and as you can see, we pass in heroes, but actually we don't know what a hero is. I mean, we know it because we created it, but we could just pass it to here, and in the IDE we would not see any error. So to improve that code, we would use type hints, and I will show you how to do this. So let's go to the type hinting IPython notebook, and now we can see here is some little markdown reasons to use type hints. So the main reasons are readability. Type hints can make the code self-explanatory. If we know what type of arguments we can pass, so is it a string, is it a number, is it a custom object, so this helps a lot. We also get tooling support. VS Code and other editors utilize type hints for better auto-completion, error checking, and also refactoring support. We can also use a static analysis tool like mypy, which can analyze our code and catch type errors before runtime. Another reason is code quality. Type hints implicitly serve as form of documentation. So when you take a look at a function or a class, you know what type of argument a function or a class expects. Okay, so this is a very basic example for type hints. So without type hints, it would just look like this. Perfectly fine, but with type hints, you can annotate the return type. You do it with this minus symbol and then the larger symbol, so it looks like an arrow, and a print statement returns nothing, so we will just return none here. We could also return a string, and this would then look like this. And if we want to annotate a parameter, we can here use colons and then the type we expect it to be. So this is a nice annotated function now. So here is the hero class with an abstract method, and yeah, that's it. And this is how it looks like without annotation, and this is how it looks like with annotation. We can see multiple stuff going on here. For example, the arguments are now here annotated with the data type. For example, name is a string, and then the level is an integer. The return type is also annotated, and also what we can annotate is the attribute type of a class. So we can set it to a string too, but normally This is not necessary. We can just leave it like this because we know that the argument we pass here is already a string, so we don't have to do it twice, but I think it's fine to do so too. So we can also define custom types, for example, this hero type. We can also define custom types, and we can use from typing import type var and then create our custom type. We give it a name, hero type, and we bind it to a specific class. So we bind it to hero. So we bind this hero type to this class. But why do we want to do this? So let's move down here to the __add method, and we can see we add heroes here. So we cannot add something which we only defined here, so we have to define a type. So here we define this hero type, and we also define this output, which is also of type hero. So when we can't access the class directly, we can also normally annotate it with just a class, so we have to define a custom type. So this is why we defined this custom type here on the top. Okay, now let's look at the team class, and as you can see, we can also annotate this team class. So what we can do here is we can provide a list. So we want to provide a list of heroes, and the heroes can be actually annotated with the class itself, and we don't need to use the hero type here because we defined that class here, and then we can use it to annotate it here later in the code. We also set the return values to none because we only use print statements here, and we annotate the heroes attribute. But normally I think that's the better way, only annotate it here in the arguments, so we don't have to do it twice. Okay, let's run the code, and as you can see, this works. So these are the basics about type hinting. Very helpful when you start building real software. Okay, another very important topic if you want to build real software is modules and packages. If you start building larger code bases, you won't put every line of code into a single file. You will build packages and then you put in modules there. So I provided you a main.py file here, and as you can see, this makes use of modules and packages. To use that, we have to install FastAPI with pip install FastAPI. So we can use an external package which is hosted on mypy. This is a repository manager with libraries you can download, and now we installed everything. And to import FastAPI, you can import the whole package here with import and then FastAPI. You can also import specific classes from a package or a module like this from FastAPI, import this FastAPI class. So everything which is not that FastAPI class won't be imported. You can also give that FastAPI class an alias. If you say as f, then you can use the f to actually instantiate that class, for example. You can also use this from FastAPI import star. This will import everything. So in general, this is not recommended. In general, you should import like this or like this. With the first statement, you could make something like this. From the FastAPI package, you could instantiate it like this, or if you import it in the second way, you just instantiate a class like this. So both are good options, but in general, this is not recommended because you don't know what you actually import and what code you execute here. We can of course also create custom packages and modules. And to do this, we have this main package folder here, and this includes modules and another sub package. So a package is a directory with an init.py. This is needed by the Python interpreter to interpret this directory as package, and the module is a Python file. So to import from that module, as you can see, we've got a function mya and mya2. So to use it, we can go to the main.py. This is here on the same hierarchy. And yeah, this is actually wrong here because it's not from module and packages, but it's from main package. And now we can import this. We can do this for the second package again. Okay, now let's remove that and call myb. So maybe let's look at b.py first. And because here we've got our myb function, and we've also got a mod b, so for module b class, and we instantiate this module b class, And this is an instance of this class, and we can also import instances. This is in contrast to Java, where this is not possible. Python is very flexible in this regard. We can create singletons like this and only use a single instance of this class in multiple parts of our code. So let's go to the main.py and now execute it. So we run Python and then main.py. So we can see this returns here module B. So this works fine. If we run mya and mya2, this will also work now. Again, have to save it, of course. And then we can see module B, module A, module A2. So this works fine. So what's going to happen if we run this? From main package, sub package, import star. So in the sub package, we've got a c.py and a d.py. So this will import from the package, from the sub package, every module. And we can now run this like this. So this is our module and this is our function inside the C module. So we can see this is defined here. But as you can see, I define that multiple times here. I execute this function multiple times. So that's why this is not a very good practice to use star, because we don't know what actually will be executed in this c.py file. As we can see, we've got multiple print statements, and normally you would expect, if you call that function, that it only prints this once. So this is very bad. Don't do this ever. Okay, that's it from modules and packages. Let's look now at the last topic, and that topic is testing. Why is testing important? Yeah, actually, because you can test your code. You can test if the functionality works as expected, and if you change anything, then the code should reflect their changes and fail. Another reason to write tests, unit tests to be specific, is actually something developer related. When I was a junior developer, I wrote code which was very hard to read and very hard to get the head around because it was just too complex. And thinking in unit tests helps you to avoid very complex functions and classes. So if you ever write a test for a class or a function and you think, oh, that's way too difficult, I cannot write a test, I'm just too stupid for writing a test, then normally it's not because you're too stupid for writing a test, but because your code is too complex and you should refactor it. So that's why I think unit tests and writing good unit tests is even more important than actually for the sake of having tested software. It's just a very helpful tool to write high quality code. So for testing, you've got the basic unit test framework for Python, or you can use the Pytest library. I'm a big fan of the Pytest library. It makes testing so much easier. You get a lot of very helpful tools that makes testing so much more fun. So in this case, we've got two functions, or better said, one function and one class. So very easy code, but it shows the very basics of testing. So we got this script.py and we want to create a test. So the convention is to write test underscore and then the name of the module you want to test. So script.py gets test underscore script.py. That's the convention. So let's start with the first example. We've got this isAdult function, and this takes a single argument, which is an integer normally. We could also make type annotation here, of course. So this is a little bit more clean. And this will also return a boolean. Let's just make everything correct and apply what we've got learned so far. So now what we can do is we can write a test for that. In the test script.py, we can now import Pytest. And what do we want to test? So first we define this test function. This is like in the module. Default is test underscore. Actually, Pytest needs this function to be called test underscore. Otherwise, it will not make a test case for that. So that's the function isAdult, and test underscore isAdult is the function name for the test. So we use assert, and assert checks if isAdult 20, so with one argument 20, equals to true. And if the value is below 18, it should return false. This is what we defined here. So over 18, it will return true, otherwise false. This is the expected behavior of our test. So let's comment that out first and run the test. To run the test, we can just, let's go back here to the root path and then to the testing directory. So with cd we go in there and then we just run Pytest. So Pytest will now check for our test script .py file and then run all of the tests. We've only got the single test, and if everything passed, we will see it like this. It's in green and 100% of the tests passed. If this does not work, we will see that the tests are now red. So we expected a different behavior than what we've got in our test. So this test failed. So either the test is false or our function does not do what we expect. So let's fix our test. So this should now work. And then let's go to the second test. So we can, of course, instantiate classes in a test file and then just test methods of this class instance. So what we're gonna check here is the getAge function should return the age property. So we define it here as first argument, which was 25. So we can assert that getAge returns the value 25. So if we save this and run it, this should now return everything in green. We can see 2 tests passed, so everything works as expected. Okay, now let's have a look at a fictional example. This is in the fourth test. So here we use something different. We use this patch object or patch function from unit tests. So you can mix unit tests and Pytests, that's no problem. And what we want to do here is we want to patch the getAge method from the user class. So why do we want to do this? In many cases, you create classes which make API calls or query a database. So you want this test to work independent from the database or the API. So if the database is down, our unit test should not fail. So in this case, the getAge method mimics a database connection, and we want to patch that. So to patch it, we have to patch it with the path where the method is defined, not where it is used. So it is defined in script.py and then in the user class and then in the getAge method. So this is the path to our function, and then we can define or mock a return value. So normally the return value is what you pass here. So this returns the age property, but we can mock a return value or patch a return value and set it to 30. So now we can assert that the getAge method returns the value 30. So this is our mock database, and we can just run it like this. And as you can see, 3 of our tests passed so far. Okay, that's it for the very basics in unit testing. Unit testing can be a lot more complex, but I think for an introduction, this is fine. So we will have a look at our very last topic, which is tooling. Normally in Python, you want your imports and your code in a specific way that other developers and you in the future can read it with ease. So there are some tools like isort, then black and mypy, which help you to write better code. So we've got this unformatted script.py, and yeah, I think the auto formatter did something here, but I think in general it's still unformatted. Okay, so if I save this, yeah, the black formatter will do this for me because it's part of VS Code. And first, let's install some packages. So black is already integrated into VS Code. Isort is not. And then we also import or install mypy. This is a static type checker. And then we also want to install Flake 8. This is a linter. So these 4 tools help us to write better code. Okay, let's first clear the prettier. So if we save again, yeah, it does work automatically. So that does not work, unfortunately. But if we go to the terminal, and then we can now, after installing black, we can run black and dot, and this will format all of our code. We can see 8 of our files were here formatted and the others stayed the same. So for this I had to save, but yeah, again, this does not work. But black will actually introduce these 2 lines between an import and a function definition, and also between this if name equals main. And then, yeah, that's it for black. So black formats your code. Then you've got isort. I will just run it here on unformatted script.py. And as you can see, nothing happened here. If we save that and run it again, you can see that isort introduced a new line here. So why does this happen? There is a specific sorting algorithm in isort, and first on the very top you've got your future imports. Then you've got your standard library imports. Standard library are part of Python. You don't have to install everything. For this YAML, you actually have to install it with pip install and then pyyaml. So this is not a standard library import, but a related third-party import. So the standard library import and the third-party imports are separated by a new line. And after that, you could import your custom functionalities, so your specific and own code. This would be, again, a new line and then your own code here. So this is how isort sorts your imports. Now let us use flake8 and then the unformatted script. And as we can see here, this is a linter and it complains about one specific import here. So we import at the top the OS library. As you can see, this is grayed out a little bit in the editor, but it does not produce an error or anything. It is just unnecessary code. This is what a linter is for. So this will not produce an error, but it's not good practice to import anything which you don't use in your code. So this is what flake8 complains about. And if we remove it and run it again, we can see there is no complaints by the flake8 linter. Okay, let's have a look at the last tool, which is mypy. So in the mypy, we can create an ini file. We can also do it for flake8, but for this, it was actually quite important. I will show you what this does. So we run mypy and then also the unformatted script.py. And as you can see here, we've got one error, and this is the no undefined type def. So this error is forced because in the mypy.ini file, we disallow untyped definitions. So if we set this to true, we are not allowed to create functions without type annotation. So we have to create a type annotation for this function to prevent this error. So let's fix it and provide the type annotation for the arguments. This will be an int, and the return type will also be an int. So we add two integers, return an integer, and if you run that again, we can see no issues found in one source file. So this is how we can fix that mypy error. So if we want to force an error, if we have unannotated types, just add this mypy.ini file and set disallow untyped defs to true. Okay, that's it. I think these topics which we learned in the last hour are the most important topics for Python developers. After learning these topics, you can jump into frameworks, and I think you are even ready for a junior developer position in Python. There are of course also another topics you have to learn, but just from the Python standpoint, this 20% of Python guarantees you 80% of the outcomes. So if you liked the video, feel free to subscribe to my channel and like the video. Thank you very much. See you. Bye bye.